Calculating the load current is an essential step. The compressor RLA is 26.4 amps. The fan motor RLA is 26.4 amps. The total RLA is 26.4 amps plus 26.4 amps, which equals 52.8 amps. Inrush current is another important factor. The locked rotor amps or LRA of the compressor motor, 134.0 amps, is significantly higher than the RLA. Inrush current occurs when the motor starts and can be 6 to 10 times the RLA. We can estimate the inrush current by multiplying 6 by 26.4 amps, which equals 158.4 amps. Circuit breaker sizing is critical for safety and proper operation. The minimum circuit breaker size is determined by the total load current, including inrush current. The inrush current can be ignored if it is less than 5 times the RLA or if the circuit breaker is rated for heating, air conditioning, refrigeration applications. In this case, the estimated inrush current, 158.4 amps, is more than 5 times the RLA, which is 52.8 amps. Based on the calculated load current and inrush current, the 60 amp circuit breaker is the minimum required size for this air conditioner unit. Downsizing to a 2-pole 50 amp circuit breaker is not recommended as it is likely to trip due to the high inrush current. It is important to use a HACR type circuit breaker to handle the high inrush current. It's imperative to understand the implications of these calculations to avoid electrical hazards and ensure the longevity of the air conditioning unit. Ignoring these factors could lead to frequent tripping, damage to the equipment, or even fire hazards. Therefore, always adhere to the manufacturer's specifications and consult with a qualified electrician for any electrical work related to air conditioning systems. Understanding the components like the compressor, fan motor, and their respective RLA values is crucial for accurate load current calculation. The compressor is responsible for compressing the refrigerant while the fan motor circulates air across the coils. Both components contribute significantly to the overall load on the circuit. Always refer to the nameplate of the air conditioning unit for the specific RLA values, as they may vary depending on the model and manufacturer. When it comes to inrush current, remember that it's a temporary surge of current that occurs when the motor starts. This surge can be several times higher than the normal operating current, which is why it's essential to consider it when sizing the circuit breaker. The LRA value on the nameplate indicates the maximum current the motor will draw during startup. The HACR rating on a circuit breaker signifies that it is specifically designed to handle the high inrush currents associated with air conditioning and refrigeration equipment. These circuit breakers have a delayed trip mechanism that allows them to withstand the temporary surge without tripping unnecessarily. Using a standard circuit breaker in place of a HACR type can lead to nuisance tripping, especially during hot weather when the air conditioning unit cycles on and off frequently. Always prioritize safety when working with electrical systems. Turn off the power up to the circuit before performing any work and use appropriate safety gear such as insulated gloves and eye protection. If you are not comfortable working with electricity, it's best to leave the job to a qualified electrician. In addition to the circuit breaker size, it's also important to ensure that the wiring is properly sized to handle the load. Undersized wiring can overheat and cause a fire hazard. Refer to the National Electrical Code or NEC for guidance on proper wire sizing. The NEC provides tables that specify the allowable ampacity of different wire gauges based on the type of insulation and installation method. When selecting your circuit breaker, choose one that is specifically designed for the type of load it will be protecting. Air conditioning units require circuit breakers with a higher interrupting capacity to safely handle fault currents. The interrupting capacity is the maximum amount of current the circuit breaker can safely interrupt without failing. Always check the circuit breaker's label for its interrupting capacity and ensure that it is adequate for the application. Regular maintenance is also essential for ensuring the safe and efficient operation of the air conditioning unit. Clean the coils regularly to improve airflow and prevent the unit from overheating. Inspect the wiring and connections for any signs of damage or corrosion. Replace any worn or damaged components promptly. A well-maintained air conditioning unit will not only operate more efficiently but also last longer. Consider the ambient temperature when calculating load current. Higher ambient temperatures can increase the current draw of the air conditioning unit. The NEC provides correction factors that should be applied to the allowable ampacity of conductors when operating in high ambient temperatures. These correction factors help to ensure that the wiring is properly sized to handle the increased current draw. Also consider the voltage drop in the circuit. Voltage drop occurs when the voltage at the air conditioning unit is lower than the voltage at the source. Excessive voltage drop can cause the unit to operate inefficiently and can even damage the motor. The NEC provides guidelines for limiting voltage drop in branch circuits. To minimize voltage drop, use larger wire gauges and keep the circuit length as short as possible. When installing a new circuit for an air conditioning unit, be sure to follow all applicable codes and regulations. Obtain the necessary permits and have the work inspected by a qualified electrical inspector. This will help to ensure that the installation is safe and compliant with all applicable standards. Understanding the relationship between voltage, current, and resistance is essential for working with electrical circuits. Voltage is the electrical potential difference between 2 points. Current is the flow of electrical charge. Resistance is the opposition to the flow of electrical charge. Ohm's law states that voltage is equal to current times resistance. This law can be used to calculate the current in a circuit if the voltage and resistance are known. Power is the rate at which electrical energy is transferred. It is calculated by multiplying voltage by current. The unit of power is the watt. Air conditioning units consume a significant amount of power, which is why it's important to use energy-efficient models. Energy-efficient air conditioning units can save you money on your electricity bill and reduce your carbon footprint. When choosing an air conditioning unit, look for the Energy Star label. Energy Star certified units meet strict energy efficiency guidelines set by the Environmental Protection Agency. These units typically use less energy than standard models and can save you money over the life of the unit. Consider using a programmable thermostat to control the temperature in your home. Programmable thermostats allow you to set different temperatures for different times of the day. This can help you to save energy by automatically adjusting the temperature when you are not at home or when you are sleeping. Another way to save energy is to properly insulate your home. Insulation helps to keep your home cool in the summer and warm in the winter. This reduces the amount of energy needed to heat and cool your home. Be sure to seal any air leaks around windows, doors, and other openings. Air leaks can allow heat to escape in the winter and enter in the summer, making your home less energy efficient. Consider using window coverings to block out sunlight during the hottest part of the day. Window coverings can help to reduce the amount of heat that enters your home, making it cooler and more comfortable. Proper maintenance of your air conditioning unit is essential for energy efficiency. Clean the coils regularly to improve airflow and prevent the unit from overheating. Replace the air filter regularly to ensure that the unit is operating efficiently. A dirty air filter can restrict airflow and cause the unit to work harder, which wastes energy. Consider using a whole house fan to circulate air throughout your home. A whole house fan can help to cool your home by drawing cool air in from the outside and exhausting hot air from the inside. This can be a more energy efficient way to cool your home than using air conditioning alone. When replacing your air conditioning unit, consider choosing a model with a higher seasonal energy efficiency ratio, or HACR rating. The HACR rating indicates the energy efficiency of the unit. A high HACR rating means that the unit is more energy efficient. The minimum HACR rating for new air conditioning units is 14, but you can find models with HACR ratings of 20 or higher. While units with higher HACR ratings are more expensive upfront, they can save you money on your electricity bill over the life of the unit. In addition to HACR, also consider the energy efficiency ratio, or ER rating. The ER rating is a measure of the cooling efficiency of the unit at a specific operating point. A higher ER rating means that the unit is more efficient at the operating point. ER is typically measured at a temperature of 95 degrees Fahrenheit. Consider the size of your air conditioning unit when choosing a model. A unit that is too small will not be able to cool your home effectively, while a unit that is too large will cycle on and off frequently, which wastes energy. The size of your air conditioning unit should be based on the square footage of your home and the climate in your area. Consult with a qualified HVAC contractor to determine the appropriate size for your home. Also consider the type of air conditioning unit you need. There are several different types of air conditioning units, including central air conditioners, window air conditioners, and ductless mini-split air conditioners. Central air conditioners are the most common type of air conditioner and are used to cool the entire home. Window air conditioners are smaller and less expensive than central air conditioners and are used to cool a single room. Ductless mini-split air conditioners are a good option for homes that do not have ductwork. They consist of an outdoor unit and one or more indoor units that are connected by refrigerant lines. Also, consider the features of the air conditioning unit. Some air conditioning units have features such as programmable thermostats, remote controls, and air purifiers. Programmable thermostats allow you to set different temperatures for different times of the day, which can help you to save energy. Remote controls allow you to control the air conditioning unit from anywhere in the room. Air purifiers help to remove dust, pollen, and other allergens from the air. Be sure to choose an air conditioning unit with the features that are important to you. Understanding the different types of refrigerants used in air conditioning units is also important. Refrigerants are the chemicals that are used to cool the air. The most common type of refrigerant is R-410A, which is a hydrofluorocarbon, or HFC. However, R-410 is a greenhouse gas and is being phased out in favor of more environmentally friendly refrigerants. Newer refrigerants such as R-32 and HF-1234 have a lower global warming potential than R-410A. When replacing your air conditioning unit, consider choosing a model that uses a more environmentally friendly refrigerant. Always be aware of local codes that can affect your installation of your air conditioner system.